Everyone. This time we are going to complete the electrical resistance notes, and this notes here is actually on par with the Google Slides which I have given. So just make your way to the Google Slides and you will see that most of the components or even most of the notes are very similar. All right, first dot point. What is the resistance of a component to the current and voltage? Well, it's definitely the Ohm's law. All right, OHM apostrophe S. So if you can fill that section, that would be fantastic. Second dot point. The components of Ohm's law are, if you can remember, it will be the voltage, the current, and of course the resistance. Okay, just make sure that you have all these three items in your notes. And of course, down to the third point is the property of an electrical conductor that opposes the flow of electrons. As you can imagine, not imagine, as you can remember, it is known as your resistance. So there you go. And resistance in this case is measured in ohms, all right? Ohms. And the symbol here would be your omega. So if I need to search for it, for example, I just type in omega. And sorry, not omega. I think ohm would be much better. All right, so there's an ohms, so I just have to click it. And if I were to X this, ta-da, here you go. Okay. Now, on to this point. These are materials that provide dash resistance, and it starts with a C. So obviously here would be your conductor. And materials which are conductors are low in resistance, right? And as opposed to your conductors, the opposite of conductors would be your insulator. And these are materials that will provide high resistance. Okay. Now, these are the three factors that we are looking into in terms of resistance, right? The first one here would be the type of material. If you can remember the second type, bravo, that would be the length of the wire. And of course, the third one here is in terms of the thickness. Okay, so just make sure you go back to the slides, check again and see whether, any of the words here complement or are the same with the slides. All right, if it's not, please inform me. Okay, that will be for the notes section. Let's move on to problem number 5 now. And here we are going to apply our Ohm's law, if you can recognize the pattern. All right, a filament bulb has a current of 0.2 ampere running through it with a potential difference of voltage of 5 volts across it. What is the resistance of the filament in the bulb? Right, what you can do at this point here is to list down. So I is equivalent to 0.2 ampere. Your voltage here would be 5 volts, and you need to calculate your resistance. So obviously we need to use the Ohm's law formula. Now what I would suggest you to do, in the space around here, draw the triangle of V on the top, I, and also R. So if I need to find out what is R, I will cover R, and definitely you will get V over I. So in this case here is 5 divided by 0.2, and that will give you 25. But it's not just 25, it is ohm. So now I will just have to copy this symbol and place it next to it. Okay, so 25 ohm is your answer for this. Problem number 6. If you were to use the Ohm's law equation, you will know that the voltage is equivalent to the current and multiply by the resistance. So we have to work a little bit backwards. If I want to find my current, I need to find this number which I multiply by 2 gives you 24. So let's try to have 24 divided by 2, and that will give you 12. Same goes for the resistance, 48 divided by 6, because you're making the resistance as the formula. as the the main variable. And if you look at this, that's what we have done. R equals to V over I. So therefore, in this case here, 48 divided by 6 will give you 8. Again, this is the same as the first part. So therefore, 12 divided by 4 will give you 3, because you're looking for the current. So once you rearrange the equation, you will get the hang of what Ohm's law is all about. Okay, now on to problem number 7. You need to solve all the missing values. All right, component 1 is the resistor, which is what I'm pointing at the moment. Component 2 is the light bulb, which is now what I'm hovering above. All right, so we recognize that this is in a parallel circuit, because remember, you have the same length and it is at a distance. Okay, so in this case here, our voltage is the same that is coming from the battery, the same energy source coming from the battery. And if you look at the first component, if you look at the first component here, it is 11 volts. If you look at the second component, it's also 11 volts. So that will tell you the total voltage here is V1 equals to V2. So 11 volts would be our answer. The next one here is current. And of course, current is different because you have an additional branch. Remember, when you have a parallel circuit, it is an additional branch. So therefore, in this case here, you have I1, right? The current that flows through the first component as 4 ampere, and the current that flows through the bulb here as 8 ampere. So we know that the total is the addition of these two values added together. So that would be 12 ampere in total. Now, if we want to calculate the total resistance, again, remember the example that we had done before this, R equals to V over I. So in this case here, my answer should be 11 out of 12, and I just have to copy that omega symbol. Here we go, and I'll paste it here. Now, if you are inserting here in a decimal number, right, just make sure you put it to the nearest 2 decimal points depending on how it is like. But because it will get messy, as this here is a repeated number, all right, it's a reoccurring number. So the best here is to leave it in its fraction form, but it's not wrong to write in the decimal form. I think it's 0.926, but please double check. It's either 0.96 or 0.296. Please check for me. All right. So thank you for listening. I'll catch you all later.